Hello all, in this tutorial I am going to teach you about windowing and clipping. Now these two may be different words, but these two are interrelated when it comes to any of the modeling softwares. Windowing is very much important to increase the scale or decrease the scale of any of the entities related. That explanation I am going to give you, and also the importance of it, the application point of windowing and clipping also I am going to discuss in this session. Okay. Coming to clipping, again this is also interrelated with the windowing topic. Let me talk about windowing first, and the second part I'll talk about clipping. Now coming to windowing, how we need to define it. Now whenever we talk about window, which is part of CAD system, computer aided designing. If you deal with any of the softwares like CATIA, ProE or Creo, then we need to deal with draft sheet also. In case of using a draft sheet, we need to present all the views in a single sheet. For example, if this is the draft sheet, let us imagine this as the draft sheet with all the details related to that particular sheet, followed by maybe I need to fabricate few components related to any of the system. Then different views of that particular component or different components going to be presented here. Whatever the views may be, that are going to be presented here. It is not compulsory that we need to present all the entities with same scale like 1:1. It is not compulsory, and it is not possible also. In few cases you may deal with multiple components, and those multiple components will have different sizes. Okay, the size of one component may be different, the size of another component may be minute. In such scenario, that minute component size has to be enhanced by increasing the scale to 1:2:1 or else 5:1. In some cases the object size may be a bit higher, large in size. In such scenario, it is not possible to show in 1:1 ratio. We need to show it with 1:2 ratio. This might be the case, nothing but scaling it down. We call this as the reduced scale, and these 2:1 and 5:1 as the enlarged scale. Okay, enlarged scale. This is how we do the practice. But this reduced scale as well as the enlarged scale both need to be drafted in the same sheet. In such scenario, we need to deal with viewport now, which is a part of modeling. This discussion or this understanding will be better about a viewport in case of AutoCAD software. If you are familiar with the AutoCAD software, then you understand what exactly viewport is all about. That is what you do. In general, this is a general discussion that I am trying to put in front of you before I actually move on to the concept. Okay. So what actually windowing is all about? Coming to the first point, simple definition: window is finite portion of infinite world. You can say it as it is a finite portion of infinite world. Means it is limitless. The space available on the graphic window is limitless, but we need to use a specified portion out of it. Now if you are very good at any of the modeling softwares, if you pan the graphic window where you are going to draw your sketch, you keep on pan it, you keep on get the graphic window. There won't be any end. It is a endless window, so you can draw as many sketches as you want. That is the scenario. But we don't need the complete world coordinates. What actually we need is, we want to project the same specified zone to our screen coordinates. Okay, we need to do according to our screen coordinate system. So out of infinite world, we are going to pick the finite portion. Try to understand, out of infinite world we are going to pick the finite portion to make it visible on the screen coordinate system, which is where you could see all of them with different sizes, different shapes, different scalings that can be taken, print and send it to the shop floor for manufacturing. Alright, this is how it goes. And let me draw a simple sketch for your better understanding. Let me clear this information on this fresh page. Again, I'll try to draw. Let me clear that I am talking about windowing first. Okay, here I am going to draw a simple sketch. Let me call this as x-axis and this as y-axis. Let us consider this as the graphic window. Okay, with let me call this as world coordinate system. Similarly, parallel to this, I'll try to draw one more. I'll try to sketch. I'm calling this as screen coordinate system. Okay. Now, in this world coordinate system, which is here I call it as 0, 0 origin. In this world coordinate system, let me select a small, simple, single window. I'll change the color for your better understanding. Here, what I'm going to draw is, I'm going to pick, let me change the color. Here I'm going to pick a graphic window. Let us consider this as a graphic window. But when you deal with modeling software, this won't be of this kind. You have to drag a window actually. So when in case of modeling software, from one corner if you drag, it will end up diagonally at the another corner, at this corner. This is the window what you call in actual practice. But for your understanding, I'm making it with a dashed line. So as this is x-axis, this is the nearby point to the x-axis. I'm calling this as x minimum and this one as x maximum. Similarly, here y minimum and y maximum. With respect to whatever the window we have dragged, this becomes y minimum and this becomes y maximum. This is the data. Okay. Now try to understand, out of world coordinate system, I am picking the finite portion which I am calling it as a window. Okay, I am calling this finite portion as a window. Okay, this is the window, and the complete portion I am just calling it as a finite portion, because for your understanding, finite portion means we are trying to pick the finite portion out of infinite world, because that is what we would like to project on the screen. Okay. Now when I drag a window, maybe some entities are already existing on the screen. Let us imagine some entities are already existing on the screen. So in such case, what actually we'll try to do, let me place few lines. Now when I drag this window, what I could see is a line is coming inside the window, okay, and a circle is inside the window, and one more circle may be partially in and partially out of the window. Okay, and there is one triangle which is partially in and out. This is what happened when I randomly pick a finite portion. I'm calling it as a. So now this particular portion has to be projected on the screen coordinate system, because we actually work on screen coordinate system. So we'll compare the same scenario with respect to screen coordinate system. Whatever you pick here in world coordinates, that is going to be visible on the screen. Okay. Let us imagine this as a screen coordinate system. I'll just, for your better understanding, I'm going to close this as the screen. Let us imagine this as a screen, and same window, whatever we have dragged there, that you could see here. Now any screen, whatever the screen monitor you consider, whether it is a laptop or a desktop, it is going to divide, the complete portion of the screen is going to divide into 9 different segments. This is how it is going to divide. Okay, 1 2 3 4 5 6 7 8 9 different portions got divided. So when the same finite portion project on the screen coordinates, what happens here is the same entities, whatever the entities got selected, are going to visible in this way. The line which is completely inside is visible to us, the circle which is completely inside is visible to us, and the triangle which is partially in, that is what visible, and the circle which is partially in is visible, and the line which is partially in is visible. All other are completely outside. So this portion is not visible to us. This portion is also not visible on the screen coordinate. This portion is also not visible on the screen coordinates. Means the entities whichever you want to show on the screen coordinates can be selected with the help of a window, which we call it as a finite portion out of an infinite world, that is going to be visible to us. So here, whatever we are calling it as a window, this portion, this rectangular hidden line, we are calling it as a finite portion or a window. The same window, when it comes to screen coordinates, it is called as, this is called as a viewport. So whatever comes inside the window are visible, whatever goes out of the window are completely invisible to us on the screen. That is what happens, that is the importance of this particular windowing. This will help us in case of drafting the application point. I'll talk about the application point also. This is what we call this as the mapping of finite portion on the screen. So whatever the finite portion picked, that we are going to map on screen, because we are dealing with a screen coordinate system where the resolution is 1024 by 1024 in general. Okay, coordinate range what you call. So whatever the information you have picked from the world coordinate system going to be visible in a coordinate range of 1024 to 1024. This is what happens. Now when it comes to screen coordinate system, the top corner always called as the origin 0, 0, because if you now here, as this is this we call it as x minimum, the way we have shown in world coordinate system, this as x maximum, followed by here again y max, here it has y minimum. Here the minimum is above because the origin is at the top left corner. This is what happened. This is the information that you people need to understand to know about windowing properly. What are the important terminology that you need to remember is, windowing is finite portion of an infinite world. The first point, let us imagine this as the finite portion. If you consider this as the finite portion, then what happens? If this is a finite portion, we call that as a window. Now when you pick this window, when you drag this window, whatever comes inside, whatever the entities comes inside the window are visible, and which are outside the window are completely invisible. So when the same thing going to project on screen coordinate system with a resolution of 1024 by 1024, the visible things are clearly seen, invisible things are deleted, disabled completely. Okay, so what happens, that disabling or that intersection, that we need to know. For example, here this is one intersection, number 2, here it happened, the calculation, that calculation we'll discuss in clipping. So when the triangle is partially in and out, here it is intersecting with the window, here also at this point it is intersecting with the window. Okay, that intersection is automatically calculated. The program is designed or program is fed to the software in such a way that it will automatically clip the model. Okay, this portion, the green line which I am drawing here, this is nothing but the clipping of the window, clipping. Okay, clipping will automatically takes place, and this portion will get eliminated or disabled, and the remained portion will remain inside the screen coordinate system. Here we call it as a window, finite portion, and here when it comes to screen coordinate, when it comes to our screen, we call it as a viewport. The window is called as a viewport. Okay, where multiple changes can be done in that particular viewport, that is possible. Fine. And as far as viewport is concerned, number 2 point, viewport is part of complete screen. Okay, where I said the complete screen is divided into 9 different segments, and whatever picked from the world coordinates going to be visible at exactly at the middle of the screen, middle of this particular screen, whatever the screen, the middle of it is going to be visible, all other sides going to be empty. Okay, sides of that going to be empty. So as here this is the only visibility area or visibility zone, here all the codes, there is a bit code what you call, all the codes are going to be zeros, all the bits are going to be zeros. That comes under a topic called 4-bit coding. When all the bits, now each and every box out of 9 boxes, each and every box will have 4-bit code, each and every box will have 4-bit code, and each bit called as first bit from right to left, first bit called as x minimum bit, similarly second bit called as x maximum bit, and next one is y minimum, next one is y maximum bit. So each and every box will have x minimum, x maximum, and y minimum, y maximum information. So when all 4 bits satisfies, with zeros, when all 4 bits satisfied with 4 zeros like x minimum 0, x maximum 0, y minimum 0, y maximum 0, then that zone is nothing but the middle portion, that area is nothing but the middle box area, where when all the 4 bits are zeros, then it is completely visible zone. That's what we call. The logic I am going to explain in the upcoming videos. How to get all the 4 as zeros. If something goes like, if something, for example, if one of the bit is 1 or two of the bits are 1, then that box is not going to show any of the entities on the screen. This logic I'll explain you in the upcoming topics. So here viewport is a part of complete screen which comes exactly in the middle. The entity size and coordinates are different from world coordinate system. For example, here the line, circle, triangle, another circle, another line. There are many, some 5 different entities I have taken. So out of these 5 different entities, once you drag or select with the help of a window, when it comes to screen coordinate system, the sizes will not be same. The size and coordinates, the size and coordinate of that particular entity will change. Okay, from world coordinate system to screen coordinate system, there is a slight variation in the size and the coordinates also. Okay. Coordinates of world coordinate system are, it will range, now when it comes to world coordinate system, it will range from minus infinity to plus infinity. There won't be any limit, it is endless. Okay, means if they are within the window, they are in the range of x minimum, x maximum and y minimum, y maximum. As I said, if they are within the window, so then the range is from x minimum to x max, y minimum to y max. Okay, other than that, out of the window, then we can call it as minus infinity to plus infinity, the range will be, which is endless range, what you call. This is what windowing is all about. And nextly, let me talk about clipping. Nextly, I just want to talk about clipping. Here, let me clear the window. Let me take a fresh sheet. Here, again I am going to draw. Here, let me talk about clipping. That is about windowing. How these two are interrelated. Let me give you a brief. This is also a part of CAD system. These windowing and clipping are interrelated. Again, same sketch I'll try to put in front of you. This is, let us consider this as a simple windowing sketch. Okay, here comes x minimum and here it is x maximum, as it is a x axis, and here it is y minimum and y maximum. Till here it is fine. Okay, because here is the origin point. Now what exactly clipping is all about, let me talk about clipping first. So here let us imagine few sketches. Let me draw simple line from one point to the other, from here to something like this, one line. There is one more line here and maybe one more line somewhere here. There are 3 different lines. The name of first line, let me give it as 1 and 2. Similarly 3, 4 is second line and 5, 6 is the third line. Okay. Try to think about all the 3. The first line which I have drawn 1, 2 is a line which is intersecting with 2 more lines of the window. Number 1 is x minimum line and y maximum line. It is intersecting with x minimum line and maximum line. Here this is first point, that is, and this is second point. Coming to the second line, it is completely outside the window, which is not at all coming inside the window. Coming to the third one, which is completely inside the window. So let us talk about line number 1, 2. Let us talk about line number 1, 2. Now coming to this particular line, let me clear one thing first. Let me clear one thing here. All these why we do this clipping or windowing means to identify invisible lines and visible lines, to identify invisible and visible lines, or visibility and invisibility of whatever the entities that you are going to draw on the monitor. Now here, as this is passing through 2 of the intersections, here we need to find the intersection of the line 1, 2. Okay. Intersection of line 1, 2 has to be done. Okay, how that is going to be done? X is equal to x minimum, x is equal to, and y is equal to y maximum. By considering this simple information, it will calculate the intersection point. It will easily calculate the intersection point. What is the intersection point here? This is the intersection point. This is 1, this is number 2. Okay, with this information, it will store the information and it will calculate the intersection of that particular point. Now this intersection has to be calculated for the line which is actually cutting or in touch with the window. Okay. Now the line 5, 6 and 3, 4, line 3, 4 and line 5, 6 are completely, this is completely out, this is completely inside the window. Okay, so no need to find for these two, no need to find the intersection. To find the, now the, in actual practice, a program is written and fed to the system or the software in such a way where intersection is done automatically. Okay, for example, simple equation I'll try to put in front of you. For any, now this clipping, for this clip, there is a simple equation that need to be followed, which is, for example, C1 tends to code, let me write it clear, code intersection of, so before that we need to specify, let us imagine point number 1, P1 as the first intersection of 1, 2 intersection, and code P2 not equal to 0. Okay, C1 first intersection I am talking about, C1 code P1 intersection code P2. Let us imagine this intersection as P1. Let me write with some other color so that you will understand better. Let me take red color so that you'll understand better. This has first intersection as P1, second intersection as P2. Okay, now P1 intersection code P2 is not equal to 0. When if this is the case, then line, whatever the line you're talking about, 1, 2, line invisible completely. That line is invisible completely. And when it comes to the second C2, let me show it here, the same C2, for C2 same code P1 union code P2 that is equal to 0. If this is the case, then what happens? Line is visible, line visible completely, line is visible completely. Now if it satisfies the first equation, if it satisfies equation number 1, then line is invisible completely. If it satisfies equation number 2, then the line is visible completely. Based on these two equations, program is written for clipping, where it will show you the visible things, okay, and will remove the intersection, okay, and which will fall out of the window, are going to be removed, and only things which are inside the window are visible on the screen. So for complete visibility and invisibility, a 4-bit code is developed. 4-bit code is developed. By using this 4-bit code, we can easily find whether line is completely visible or completely invisible. That discussion we'll have it in another session. And this is all about windowing and clipping. And coming to the application point of windowing and clipping, if you talk about the application point, where exactly we use this particular windowing and clipping, if you go through any of the modeling softwares, you find different modules like part drawing and maybe sketcher, part drawing, assembly and drafting or drawing. Now when it comes to drafting and drawing, this particular windowing and clipping is very much important, because ultimate aim of any designer is to fabricate the component. You need to develop a draft sheet that has to send to the shop floor for manufacturing. So in this draft sheet, as I said in the beginning, you find different views of a component, not single component. You find maybe you need to fabricate 4 different components. Then the information of those 4 different components going to be here. As I said in the beginning, like if the object size is very minute, that need to be enlarged. If the object size is very much bigger, that need to be reduced. So you need to deal with 2 types of scalings, 1:2 and 2:1. Maybe in some cases 1:5 also be there, 1:10 will also be there. In some cases 10:1 will also be there. Okay, all the information or all the scaling need to be followed in a single window, okay, single sheet, draft sheet. To do so, viewports are very much important. As I said, viewport is very much important. This viewport will help you. For example, in this window here, in this portion, I'll try to place a viewport here. This acts as a viewport. Now in this viewport, I'll try to enlarge one entity, okay, by moving this box, hidden box, front and back, top and down, right and left, top and down, top and bottom. I can place my image in this corner. Similarly, I'll create one more viewport somewhere here, one more viewport here. I can create one more image. I can move one more image in the screen. The size of first viewport, let us call this as V1 viewport, this as V2 viewport. the image size of V1 may be different completely when you compare with the image of V2. So the size and shape, here you can maintain isometric view, here you can maintain the projections with different scalings, different colors, different dimensioning, different tolerances, or detailed drawings can be given, enlarged views can be shown. So every other information can be shown with the help of this particular viewport, which is very much important, without which you can't show too many sketches, too many views, too many sizes, shapes on the single draft sheet. That is what happens when it comes to application point. This is what we'll try to do. You understand about viewport very well in case of AutoCAD tool. Here you understand viewport in a better way. Okay. This is what I would like to present. Here I am concluding it. Windowing and clipping is a part of CAD system which is very much important for any of the modeling softwares, without which none of the modeling software will exist. Okay. The usage of viewports may be different, the presentation may be different from AutoCAD, but more or less the objective is the same. This is what I would like to present, and the upcoming session will talk about 4-bit code. This 4-bit code will help you to make the entity visible completely or invisible completely. That happens with 9 different portions of a same screen. Okay. Thank you for now. Thank you for listening. Please do subscribe, share and like the channel. If you have any queries, you can comment in the box given below. And in the description, you could see different topics related to CAD system, where this clipping and windowing will help you to form as the base for that particular topic. You will understand other topics also very well if you understand this windowing and clipping in a proper way. Thank you for now.